In this video we look at graphs of continuous functions and analyze the local, also called relative, extrema of that function. Now don't let the terminology here scare you off. Extrema are maxima and minima. Maxima is just plural for maximum, and minima, of course, plural for minimum. Okay? So no big deal. In other words, they are the high and low points on a graph. And when you're dealing with a continuous function, or just basically a smooth function with no breaks in it, then this is actually very simple. So writing it down may be the hardest part. You have to understand the way to write it. But let's do an example. So here's an example of a nice smooth function, continuous function, and we want to determine the local minima and maxima of the function. Or you could call them relative minima and maxima as well. And so what we need are the high and low points. Now there's something else called a global minimum or global maximum, also called absolute minimum or maximum, but this video is just local minima and maxima, which are all the high and low points. Now in this particular function, here is a high point which is a excuse me, which is a local maximum, and here is a low point which is a local minimum. See how easy that is? And you probably can't read those. This ordered pair is -8, -1, and this ordered pair is -4, -9. So don't think you can see those. So how do we write these answers? Well, let me show you. This function has a local maximum of -1. That's your y value. You could even say has a local maximum value of -1 at x equals -8. So that is this point right here. That's how you would describe it. The value is the y value. The y value is what makes it a maximum or minimum, right? How high or low the point is determined by the y value. And the x value tells you where. So that's why you see at x equals -8. Think of the x-axis as a timeline. It tells you where things happen, and then the y value tells you what's happening. So at -8, the value is -1. Okay? So let's say the same thing with the other point. This function has a local minimum value of -9 at x equals -4. And so of course that corresponds to this point here. The value is the y value, and it happens at the x value of -4. Now if you can have more than one local minimum, any low point, so you could have multiple low points. In fact, high points you could think of as a peak, and low points you could think of as valleys. So a function could have multiple peaks and valleys, and each one of those would be maxima or minima. So you could list multiple maxima or minima, and you would use the words local maxima values of whatever at x equals, and local minima values of the number at the x value. Okay, so just to give you an idea of what that could look like, you could have a function that looks like this. And each of these yellows are maxima, and each of the greens are minima. Okay? And so that's an example where you have four local maxima and three local maxima and three local minima.